Alright, ladies and gentlemen, this is going to be our next video on evolution and going through Hardy-Weinberg practice. Let's get started on this next video. Okay, so in a population of 1,000 giraffes, 18 have spotted tails. Now, spotted tails are due to the recessive allele. Find the allele frequency for the spotted allele, the spotted tail, the non-spotted allele, and the frequency of all genotypes of the population. So let's go through. Here's our checklist that we're going to go through and apply. We're going to have to assign the alleles. So remember, P plus Q is going to be equal to 1. P is going to be for our dominant allele. And we were told that the dominant allele is for non-spotted tails. Q is going to be for the recessive. And this is going to be for spotted tails. So this is for spotted tails. So if we're looking at this, remember our equation is going to be P squared plus 2PQ plus Q squared is equal to 1. But we need to identify what Q is before we can figure out any of the other genotypes. So if we're looking at this, Q squared is going to be equal to 18 divided by 1,000. And remember, we're solving for Q by itself. So if we go through and solve for Q, we're going to do 18 divided by 1,000. That's going to give us 0.018, and then we're going to have to take the square root of that. So when we take the square root of our answer here, we get a Q value that is equal to 0.13. Now we can figure out what P is because P plus Q is equal to 1. So if we look at this, P has to be 0.87 here. So Q is 0.13, P is 0.87. So we've gone through and completed the first two steps. Now we need to go through and we're going to use P and Q to calculate the other genotype frequencies here. So by going through and doing this, remember, P squared plus 2PQ. Q squared is equal to 1. So let's go through and calculate each of our genotypes here. So we want to go through and calculate the homozygous dominant, which is going to be equal to P squared. So by going through and doing this, we're going to take 0.87. We'll go through and square it. This is going to give us the number of homozygous dominant individuals. So 0.87 squared, well, this is going to be equal to approximately 75% of the population, or 0.75, or 75% going to be homozygous dominant here. So let's go through and do our homozygous recessive. So if we do Q squared, we're going to do 0.13, and we're going to multiply that by 0.13 or square it. So 0.13 squared, well, that's equal to approximately 2%. So approximately 2% of the population is going to be homozygous recessive. Now, if I actually have these two numbers, I don't have to do 2PQ the calculation here. I can do 75 plus 2, which we know is 77%, and then we can do 100 minus 77. So I know that 23% of the individuals in this population have to be heterozygotes, but I can go through and do the calculation anyway. We would do 2 times 0.87 times 0.13, and I would get a value of 0.23, or 23%. So what is this going through and telling us after we've gone through and completed the steps? Well, if we're looking at the allele frequency, 87% of the alleles code for the non-spotted dominant allele, and 13% code for the recessive spotted one. Now, if we look at this, 75% of the individuals are homozygous dominant, 2% are homozygous recessive, and then 23% are heterozygous. So again, what this is telling us is it's giving us a bunch of data that we can go through and use, and then we can see the allele frequencies present within those populations.